Aloha, Rich Halverson here. This is ITS388AL, and today I'd like to get you started on assignment on the BubbleSort assignment. So let me share my screen, and I think I'm going to go to this one. And so here we are, and in this assignment we are going to modify the BubbleSort program to make it faster. Let's see let's see if this, am I on the right? Let me move over to this. I want to use this browser here. Assignments. And okay, so I want to use this browser because I think I can write with this browser. Maybe not. All right, I guess it's not working. All right, so then in which case I can use this one. All right, so with BubbleSort, we have two loops. We have an outer loop, which is this whole thing. And in this outer loop, we are taking passes through the whole array. This is the inner loop. This passes through the whole array. It goes from the starting point, incrementing each time as many times as this ECX says, which starts out the entire loop or the entire array, and each time it takes a pass through, it looks at adjacent pairs of elements, and if they're out of order, then it exchanges them. And the first one should always be less than the second one. And if that's not the case, then it exchanges them. So, so if we look at a diagram here, and we start out with an array 5, 1, 4, 2, 8, and we want to get to 1, 2, 4, 5, 8, we take these passes through 1, 2, 3, and if we find a pair that is out of order, then we exchange them. So looking at the first pair here, we see it's out of order, so we exchange it, and then it's the 1. The 1 is where the 5 was, and the 5 is where the 1 is. And then you go to the next pair, and we see that's out of order, so we exchange them. And then we go to the next pair, and so on. And when we're done with one pass all the way through, you notice that the 8 is in its proper position, but there's still elements that are out of order. So we have to take a second pass through. And if we take, you know, all the passes through for every element, then at the end we're guaranteed to have a sorted, the array is sorted. Now, there's a shortcut, and that is you might not have to take a pass through for every element in the array. Turns out that if you take a pass through and there's no swaps, then you know that the array is already sorted. So in this example here, we found the position of the last one, we found the position of the second of the last one, and then we took the third pass through to find the position of the third last one, and we noticed that there were no swaps. Since there's no swaps all the way through, then we know that the array is already sorted. So in this illustration here, we're actually able to cut short the outer loop because we determined when we execute the inner loop that there were no exchanges. This program here does not have that last feature, and what the idea here is that we add that feature to this program. So so I've actually modified the link here, and the link here goes to the Irvine library that I gave you earlier, the chapter 9 the down in the Irvine library for chapter 9, and you have this, you've been using this, down in 32-bit, it is precisely this binary search program here. And I've zipped it up and put it right here, and I link to it now right here. So let's start with that. I'm going to click on that and save it. I can, why don't I open it? And it opened up over here. Let's see, can I? It opened up over here, and I'm just going to, shoots, no, forget it. Let me download it. Let me start again. Let me download it to the desktop. Save file on the desktop. And it ended up over here. And so let's open it up, extract all, extract. And we can double click on the binary search here. And if we go down here, we see sample projects. And we want to update or retarget this thing because the thing is old. So this updates it, and here we are. All right, so, and if we open up the solution here, we can see that this binary BubbleSort program is right here. All right, so in this program, let's see, I gotta make sure that I've been, for BubbleSort, yes. I hope I haven't been saying binary search. I for all my life, I've misspoken those two, but the name of the program is the binary search program, and that's really the main emphasis here, because here's binary search. Here's the implementation of the binary search program. We're focusing on the BubbleSort program, and so so what we need to do is modify this so when we get to the outer loop, instead of doing this increment or decrement of ECX and looping back to here, we want to put a counter right in here. And each time we do an exchange, here we're doing the exchange. We want to count it or set something equal to 1, saying that there was in fact an exchange in this path. So in this pass. So in this loop, it'll count up the we'll count up the exchanges, and then when we get out here, we'll see if the exchanges was 0. If it was 0, then we know we're done. All right, let's run this thing, see what it looks like. So let's rebuild the solution, and then let's run it. And this thing pops up. And first, it displays out an array that it filled. And it's not sorted. See, there's 89 there, whatever. These are all random array. And then let's hit any key. And now we see that it is sorted. It's the same array sorted. Okay, and then we can locate an integer if it's in here. Like, let's see what position minus 89 is in. So I can go minus 89, enter, and we see that it's in position 22. All right. So I want to create a second program here called BubbleSort 2, which adds that feature. And the reason I want to do that is because in a later video, I'm going to have us put in how we can count the number of milliseconds that it takes to execute the program, so we can actually compare the performance of these two. But that's not this assignment. In this assignment, we're just going to add the little feature in there to cut the outer loop short when we know that the array is already sorted. So so I'm going to make a copy of this. How do I do that? I'm going to just do a right click here and do add a new item. And I'm just going to call it BubbleSort2.asm. So I got a blank thing here, and I'm just going to copy all of BubbleSort1, copy and paste it over to BubbleSort2. I got to change all of these things to 2. Okay, is that it? I think so. And all right, so we want to, in the outer loop, okay, this is the outer loop just before it enters the inner loop. This is the inner loop. So let's put a, let's use EBX. Okay, I'm going to use EBX to be the counter. So I'm going to do space EBX. And I'm going to say use EBX to count the exchanges in the inner loop. If no exchanges, then we're done. Something like that. Whatever. Okay. So this is, it comes in, it stores the count in the ECX register, and the reason it does that is because when it's going through its passes, it doesn't need to, the first pass has to go all the way down to the end, and at that point, the largest element is going to be at the end. The next pass does not have to go all the way down to the end, because it already knows that the end already has the highest element, so it only has to go to it, so it can go down one less. And each time it takes a pass through, it needs to go down one less because it's slowly building up the sorted array from the bottom. You know, the highest ones go to the bottom, and finally at the very end, it checks the first two elements to see that they're in order. So that's why we can decrement the ECX register. That's why in the outer loop, we decrement the ECX register. We pop it out, we decrement it, go back up here, and we push it back in again to save it, because we also use that ECX register for the inner loop, for keeping track of where we are in the inner loop. So I think I can put it maybe right here. So I'm going to say move EBX 0. Okay, 0 out the inner loop exchange counter. Okay, and then someplace if there's an exchange. Okay, so this checks to see if there needs to be an exchange. Jumps to L3. This here, this is an exchange has taken place. So right after here, I can increment EBX, count the exchange. Okay, and so this thing loops away, and then when we're done, we need to check if ECX is 0. Now, we need to make sure that we started the EBX after we pushed the counter. So after we pushed ECX, so ECX is on the stack. So we need to pop it off the stack before we decide to jump out of the loop, because otherwise our stack will be mixed up or messed up. So right here, I'm going to compare EBX with 0. Were there any exchanges. And if equal, if it's equal to 0, then we're done. So we could jump out, jump to L4. If equal 0, we're done. So jump out. All right. So that's good. So I think that'll work. All right. So I'm just gonna. Okay. So we've got a second sort program. We have to hook it up. To hook it up, we have to go to. We have to add it. We have to make a proto. We have to make a proto for it. And so to do that, up here over in the Solution Explorer, I'm going to click this Switch Views, and I'm going to click Switch to the folder so I can see this inc file. So I'm going to open up the inc file, and I got to add a new BubbleSort proto. So I'm going to do copy, and I'm going to paste another one here, BubbleSort. Faster, whatever. And I'm going to call this BubbleSort 2. I think that's all I got to do. All right, so we can switch back here. And let me save it all. Let me rebuild the solution. Okay, there's assembled BubbleSort 2, and it succeeded. So let's run it. Oh, wait a minute. I'm not doing anything to it. I have to call it. So let me go over to Bubbles, the binary search test. Okay, I never did. Have we looked at this yet? I don't think so. In this binary search test, this is where main is. It's the main here. And what does main do? Well, first of all, it initializes the random number generator, and then it fills the array. The array is allocated right here. It is array size in size, which is 50, and this low val and high val are are parameters to the fill, or arguments into the fill array program. The fill array program fills this array starting here, this many elements, random numbers between low val and high val. Then we print it out, and then we wait for the user to tap the keyboard. And then we invoke our BubbleSort program, and then we print out the array again. And then here we ask for this to find the binary, do the binary search to find the location of a particular element. Okay, so so let's run this again so we can just refresh our memories on how this works. So start debugging, and this thing pops up, and we see the random array, and click any key to continue, and now it's sorted, and we can ask for where an integer is, and what happens if we put in something that's not there. The number 1 is not there. It says the value is not found. All right, so I tell you what, first thing I'm going to do here is I'm going to just mess with this a little bit. I'm going to put the low value is equal to 1, and the high value is equal to 10,000, just because I want to see all positive numbers. And so now let's rebuild. And let's run this again. Okay, that's better. Okay, all positive numbers. Hit any key to continue. And now we see it's sorted. And it's easier to see that it is sorted. Okay, and we can look for 3078. 3078. and it is the 18th element. All right. So okay, so let's try the new array. Let's just make sure it works. Let's change this to BubbleSort 2. I'm gonna do it this way. I'm gonna comment out plain old BubbleSort, and I'm gonna replace it with BubbleSort 2. And now let's rebuild. And debug. And there's the original array. Hit the key, and we see that it does sort. It is sorted. And the key to it, knowing that it's sorted, is we can ask for the last one, 9996. And it's in position 49. All right, okay, so that looks like that works. And so I've shown you how to set this up and do the fast bubble sort. Now, in the next video, I'm going to add some stuff to be able to time these algorithms, time how long it takes. We're going to set up how to initialize the array with a perfectly sorted array and look at the times with that. With a perfectly unsorted array and look at the times for that. And that way, that'll lead us into being able to do assignment 10, or the last assignment, where I would like you to implement 2 other sort programs, and that way you can compare performance. So until next time, thanks for watching.